So we're going to start our next section, 12.3, which is about velocity and acceleration. So in this section, we're going to think about an object moves along a curve in the plane. So if you want to think about it in a picture, let's say here's my plane, and I have an object moving along this curve in a certain direction, right? And remember, we can give these with parametric equations. Or you can think about them in terms of a vector function. So I'm just going to think about it with an r of t here, x of ti plus y of t j. And this is what we would call the position vector. And so how do we get velocity from position? We take the derivative. So to get v of t, it's the derivative of our position. So this is how we get the velocity vector. We can also get speed. So if you want to get speed, what you do is you just take the magnitude of your velocity vector. So I take the magnitude of my velocity vector. It's the same thing as the magnitude of r prime. So it's take the derivative of x prime, square it, the derivative of y prime and square it, add them together, take the square root, and that's the magnitude. So that's how I get speed here. And then finally, how do I get acceleration? Acceleration is the derivative of velocity, or you can think of it as being the second derivative of position. So now that we have these all defined, let's look at a problem here. Example, let's say I have for the particle that moves along the plane curve C, described by r of t is going to be 2 sine of t over 2I plus 2 cosine t over 2j. I want you to find A, the velocity vector, B, I want you to find the speed, and C, I want you to find the acceleration. So let's start with the velocity vector. So for A, to get the velocity vector, right, we take the derivative of our position vector, which is up here. So I'm going to take the derivative of this. So don't forget, when you take the derivative, you have to do the chain rule. So the derivative will be cosine of t over 2I minus sine t over 2j. So there's my velocity vector. Now let's find the speed, was the next thing I needed to do. So to find speed, what do we need to do? We need to find the magnitude of our velocity vector. So here, if I take the magnitude of my answer from part A, I would get cosine squared t over 2 plus sine squared t over 2. And because I have the same angles in here, this says cosine squared plus sine squared, that's equal to 1. And so the speed is 1. This particle has a constant speed. And finally, part C, I was asked for acceleration. To get acceleration, I need to take another derivative, take my first derivative and take one more derivative, so it'll be negative 1/2 sine of t over 2i minus 1/2 cosine t over 2j. And there's my acceleration vector right there. Now the last thing I want to mention about this problem is if you look at your vector equation and convert it into parametric equations, x is 2 sine t over 2, y is 2 cosine of t over 2. And if you take these and square them and add them together, you'll see that you get 4. And this is the rectangular equation we learned about in the previous section, and it's the equation of a circle. So this particle is moving along a circle of radius 2. A circle of radius 2. It's moving with, we said, constant velocity. Out here. And then, depending upon your value of t, has a constant constant speed. But what's happening is this particle is moving around this circle here, and it has a velocity vector and an acceleration. So the velocity vector is going to go in that direction, and then the acceleration is going to go in that direction.